All right, okay, so our midterm exam will be on Friday, again, either 10 a.m. or 10 p.m. Just show up for the exam. So again, that's not our normal time. So we normally meet on at 11. So the exam going from 10 to noon, that's a little bit different from our normal time. But so please keep that in mind. And you'll go to the kind of the quizzes and exams section on CCLE and log into Zoom. I guess I'll put some instructions here as well. I posted up a few practice problems, but just a note about these. These problems there's a little bit more of a calculation emphasis, okay? Whereas on the midterm, there'll be a mix of kind of calculation and kind of definition / conceptual questions. It's just hard to kind of make practice definition questions or practice conceptual questions without kind of revealing what the actual questions are themselves, or giving questions that are maybe completely unrelated. So, so let me just write a note. I'll say the practice problems on CCLE focus more on calculations, and the midterm, the exam itself, will have a mix of calculation and kind of definition / conceptual questions. Okay, it's just that I haven't provided I don't have a ton of practice ones of these. That's so my apologies there, okay? Very many kind of practice problems. Okay. Kind of, I guess, tips for study. I would say go over the homework. Go over homework problems. And then review kind of the examples and lecture. And then, and I would say create a few pages, few being like less than 3, a few pages of notes that summarize key ideas. And then, either put in references to kind of lectures and page numbers. For additional detail. So just because, so there will be, I guess, five lectures, and right, because 5 lectures with 50 plus slides each. Is a lot to navigate through, okay? And, you know, even though it's an open note and open book, you don't want to have to be flipping through, you know, say 250 different slides here trying to find the thing that you need. So if you have kind of, you know, something on that you've written out as you're going through your notes and stuff, if you've written out and said, hey, you know, if you want to see an example on this kind of problem, say a probability problem where you're doing the and rule. So what you can do is like, you know, you can have a short example in your notes, and you can say, you know, for more examples, go to, you know, lecture, you know, lecture 2-2, you know, slide this number. And that will help you kind of navigate through the material, I think, during the exam. So that's a recommendation. The question, all questions will be multiple choice? Yes. So all questions are multiple choice. All questions are multiple choice. And you can use any calculator and even R. To solve problems. How many questions will there be on the exam? How many questions? I don't know. I'm still wrestling with this. I'm looking probably with them being multiple choice, probably in the vicinity of 50 to 60 questions, probably something around there. To 60 questions. This is my guess, okay? That might change a little bit. And again, it's going to be a mix of calculation and definition / conceptual questions. So there'll be some work there. Okay. Any questions on this stuff before? I was just going to do some. So you'll have 2 hours. Okay. It's either going to go from 10 a.m. to noon, or 10 p.m. to midnight. Okay, California time, and that should. I'm hoping that works. One of those times works for you. So, how much time will you be given? Yeah, that's what you have. So, okay. Any other questions? I guess just about logistic or administrative stuff. Okay. Are there certain topics or chapters that you want me to review first? Or should I just start doing different problems from the textbook, or what? I figured I don't want to do the, so I posted some practice problems, but I feel like it's better if you guys kind of just work through the practice problems on your own rather than me like doing them for you right now. So yeah, I guess we'll do, just give me a second here. All right, so we can do some probability questions. Yeah, I think chapter 5, there's probably some of the tougher questions here. So let's I guess I will, this is the second edition textbook, but let's see. So here's some chapter 5 problems here. Let's, I guess I can do some even numbered problems here. All right, and then we have a request for chapter 6 as well. Okay, chapter 5 and chapter 6. And then you want to do some stuff with R. Okay, sure, yeah, let's, we can cover all of that. All right. Okay, let's take a look at a few of these problems here. So here we've got playing cards problem, and it says also refer to chapter. So this is just some information about a deck here, chapter 511, problem 511. I guess we can answer any of these. Okay. Well, we'll just start with this. Okay. All right, so we'll look at 518. Okay, so it says if one card is selected from a shuffled deck of 52 cards, what's the probability that the card will be a club or a diamond or a heart? Okay, so here it's asking, what's the probability of club or diamond or heart? Okay, and so as far as the problems go, one important thing is that the suits are all mutually exclusive. Right? So we can, this becomes probability of club plus the probability of heart, or of diamond, plus the probability of a heart. Okay, and there's no no overlap to subtract. What's going on here? Sorry. Okay. So there's no overlap to subtract. Okay. So so this is easy. Probability of clubs, 1/4, or each suit. There's 13. 13 out of 52. So there, which is 1/4. So we got 1/4 plus 1/4 plus 1/4. And this adds up to 3/4 here. Okay. We could try, I don't know, I can make up other problems, right? What's the probability of, say, let's say, a red card or an ace? Okay. All right, so half the deck is red. And then there's 4 aces here. Okay. And here there is overlap, okay? These are not mutually exclusive, okay? Okay, so there is overlap, which is probability of red card and ace. And there's two cards that fit, okay? This would be ace of hearts and ace of diamonds. Okay, so anyway, this will become probability of red card plus the probability of getting an ace minus the overlap. So we've got 26 plus 4 minus 2. Okay, and so this leads us to a total of 28 out of 52, which I think is 7/13. This will be our answer here. All right, so that's beginning example. How would you subtract the overlap of 3 events that were not mutually exclusive? Yeah, okay. So yeah, you can also do that. So basically, you would have to just kind of break this out, okay? So if you had, say, the probability of A or B or C, okay, then first you would kind of combine these into, like, let's just call this X, right? So you'll, we'll call X to be equal A or B. And so that you'll just do this in steps, right? So you'll say the probability of X is going to be equal to the probability of A or B, and that will be probability of A plus the probability of B minus the overlap. Oops, sorry, not probability of C, probability of A and B. Okay, and then, so once you get that, then it becomes the probability of X or C, okay? And then you'll have to figure out, so this will become the probability of X plus the probability of C minus the probability of X and C, okay? And then this probability of X and C, this could get a little bit, depending on what it is, this could get hard to do, but you would just kind of break it out into multiple steps if that's what you need to do. But anyway, don't worry about this, okay? Okay, let's let me keep ticking along here. Let me see if there's another example I can do. So we have this table on the college poll. Let me scroll through and okay, let's look at this problem, 596. Also a probability thing. Okay, 2012, which should you be reviewing our past quizzes as well? You can review your past quizzes. That could be useful also. Okay. All right, it says 80% of Republicans, 59, 52 answered yes. Assume that anyone who didn't answer yes answered no. Suppose that the number of Republicans polled was 400. Okay, so I'm going to just go ahead and we'll fill out this table. Okay. All right. Total number of Republicans polled was 400. The total number of Democrats was 500. And independent was 100. Okay. All right, so we've got 1,000 people total. All right, and it said 80% of Republicans, which that is what we have, 80% of Republicans answered yes, which means the other 20% goes here, okay. 59% of independents, so we're gonna have 59 out of 100, which puts 41 here. And then, and 52% of Democrats said yes, 52. So, I don't know, 500 times 0.52, what is that, 260? Indeed, okay. Which leaves 240 here. Okay, and so this, if we do the row total, we'll do 320 plus 59 plus 260, 639. Okay, which means we have 361 over here. Okay, all right. So B, so let's fill this out, okay. What is the probability that a person randomly selected is a Democrat given that they said yes, right? So this is asking, what's the probability of a Democrat given that they answered yes, okay? And so we're gonna say probability of Democrat and yes divided by the probability of yes, right? So this is the conditional probabilities. Okay, so Democrats and yes, we have 260 total, divided by people who answered yes, which there are 639, and whatever this percentage comes out to be. Around 40.69, 0.4069, something like that. Right? Let's see. What's the probability that a person randomly selected is a Republican, given that they said yes? Okay. Should you round on the exam? Well, it's going to be multiple choice. So regarding how you should round on the exam. So the answer is, you know, you'll need to do some kind of rounding, and you'll pick the answer probably the closest one that to what you get there. So no, there's no work for you to submit. It's just going to be multiple choice. So so what's the probability that a person randomly selected is a Republican given that they said yes? Okay, so here we're going to say, whoops, probability of Republican given yes. Okay, and so this will be basically 320 divided by 639. That's something around 50%. 50.08, 0.5008. Okay, what is the probability that a person randomly selected yes, said yes, given they are Democrats? So here, we're asking for probability of yes, given that they are Democrat. Okay, so here, well, I mean, the answer is right here, 52%, but we can do this ourselves. 260 divided by the 500 Democrats, we're going to get 0.52. Yes, I said yes, given that they are Democrat. Okay. And what is the probability that the person randomly selected from the entire group is a Democrat and said yes? So this will be probability of Democrat and yes. And these are all different, right? And so this is 260 out of 1,000. So we're going to get around 26% there. Okay, so that's another problem there. Let's see. So I'm intentionally choosing even numbered problems so that, when you study and do work on your own, you can choose to do more odd numbered problems. And I think the your textbooks have the answers to all the odd numbered problems in the back. So so you should be able to check your work that way. Okay, let's look at this one right here. Are these examples okay? Is there a particular kind of probability question that you want me to review or cover? Binomials, maybe? Okay, yeah, we can do binomial problems, sure. So that will come in when we do chapter 6 problems. Okay. All right, let's take a look here. 594 says a Gallup poll asked, do you think that rich people in America today are happier than you, less happy, or about the same? 36% said less happy. 36% said rich people are less happy than them. Okay, well, interesting. All right, 11% said happier and 50% said about the same. The reason these don't add up to 100 is that there were some people who had no opinion. Suppose Gallup were to do another survey polling 1,500 per people, and the percentages were the same as those in 1990. Okay, all right. Okay, less happy. All right, so we would, okay, this was actually easier than I thought. All right, so the answer is going to just be, 1,500 times the probability. So, so less happy. So 1,500 times 0.36. What is that? 5,400. Okay. Let's see. How many would say happier? 1,500 times 11%, 0.11. 165. And what would it say about the same? Okay, and then how many said about the same? 1,500. Okay, 700, 7,500. Okay, the end. All right, I thought this was a more complex problem. Okay. 594. Okay, let's just take a look. Let's find a problem that asks for, are they independent? They're not. There's no questions here about that, is there? Okay, let's just ask. Well, I think our answer is very obvious here, but so we'll look at, say, look at 5.96, and then the question is being, I don't know, Democrat independent of answering yes? Okay. All right, and so what we want to check, we're going to check if the probability of answering yes given Democrat, is that equal to the probability of just yes, or the probability of yes given, I guess, not Democrat. It doesn't matter, okay? And if they are equal, then they are independent. And if they're not equal, then they are not independent. Okay, so probability of yes given Democrat is right here, 260 out of 500, 0.52, okay? And then, and we could either just check probability of yes in general, which is 639 out of 1,000, so 0.639. Or we could do probability of yes given not Democrat. And this would require a little bit more work. We'd have to do 320 plus 59 divided by 400 plus 500, or 400 plus 100. So I get 379 out of 500, and that's, what is that? 0.758. Okay, and so these are not equal. These things are not equal, which means they are not independent. Why would we pick one over the other? It doesn't matter. So whichever one, I guess, is easier to calculate. If they're independent, then all of these things would be true. Probability of yes being Democrat would be equal to the probability of yes given not Democrat, or just the probability of yes in general. And so in some cases, certain one of these things might be easier to calculate than the other. So so you know, if these two are not equal, then these two will not be equal, and these two will not be equal. And if these two are equal, then all three would be equal also. So it doesn't matter. So you can find any of these three and check if any of them are equal or not equal. Okay. Yeah, I guess we can do kind of some binomial type problems, or things that are sort of binomial and not really. So here we have some sequences of independent events, which is not the same as binomial, but then we can do binomial type problems as well. So we have seatbelt use. All right. It says 84% of drivers buckled their seatbelts. Assuming that this percentage is still accurate, or assume, if 4 drivers are randomly selected, what's the probability that they all wear their seatbelts? Okay. So here we've got probability equal to 0.84, and then we have 4 drivers. Okay. So this could be binomial, but we could just basically have either yes with probability 0.84, yes wear their seatbelt, or no with probability 0.16, right? Okay, so all are wearing their seatbelts means we have to have yes, 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 and yes, which would be equal to 0.84 raised to the 4th power. I need my scientific calculator for this one. Okay, and I get 0.4979. Okay, 0.4979. Okay, and that's that. That one is simple. We could easily make this binomial though. Okay, and I could do. I could say, what is the probability that 3 wear their seatbelts? Okay, and 3 wearing means implies 1 is not wearing, right? Okay, so in our case, let's figure out our n, our p, and our x. So we have 4 drivers. Our p is still 0.84, and our x in this case is 3. Okay, and so the binomial probability, so now we're in chapter 6, the binomial probability would be the number of arrangements times the probability of success raised to the number of successes times the probability of a failure raised to the number of failures. Or we would write this as n choose x, p to the x, 1 minus p raised to the n minus x. Okay, so I've got 4 choose 3. P raised to the x is going to be 0.84 raised to the 3rd power times 1 minus p, which is 0.16, and that's going to get raised to the 1 power. All right, so on my calculator, I can do 4 choose 3 easily, and the answer is just going to be 4, but I can do 4 shift divide 4 choose 3 and I hit equal, and that's going to be 4 times 0.84 raised to the 13 raised to the 3rd. 0.84 raised to the 3rd is 0.5927 times 0.16 raised to the 1 is this. Right, so I'm going to multiply this times 0.16 times the 4. Total probability is 0.3793. Okay. This can also be solved in R. So there's a question about using the choose function. All right, so there's a, so here I am in R. So I could do choose, and in our case we want 4 choose 3. So we would write 4 comma 3. So we do choose 4 comma 3, and we get 4 here. And then so I can do choose. I mean I could do 0.84 raised to the 3rd times 0.16 raised to the 1, and I get the same answer here. I can also go directly using dbinom, and in this case, when you type in dbinom, R gives you a hint. It says X size probability. Also, if you forget how to use it, you can also just do a question mark on dbinom, and it lists it off. It kind of gives you the X and the size and the probability, size being your n here. So we could just do dbinom 3 out of 4, and the probability of success is 0.84. So how many successes? The X is 3. The size, or our n, is 4. Probability of success is 0.84. This is also going to give us 0.379336. Okay, so same answer as we got over here. Is that okay? I'll copy this. These are all just ways you can. Same answers here. So if you want to, you are allowed to use R for for this. So we can do another problem here. Here, let's try another problem. We'll skip ahead to chapter 6, which I think let me try. Let's try some of these problems here. Okay, I guess we'll do 674. Book needs a few more examples here. Okay, so we got 674A. All right, so 2013 poll indicated that about 80% of households had access to a high-speed internet connection. Suppose 100 households were randomly selected. How many would you expect to have access to high-speed internet? Okay, so here this is, we're asking for the mean, which is equal to n times p. So in our case, if we have 100 households, and we expect 80% of them to have internet, we would expect something around 80 to have high-speed internet. Let's go ahead and try some of these problems over here. Okay, so part B says if 10 households are selected randomly, what's the probability that exactly 6 have high-speed access, right? So for part B, we have n is equal to something, p is equal to something, and x. So we have a total of 10 households for n. Okay, this is our n here. And then 6 is our x, and then 80% is our p, 0.8. Okay, so so we could use this, and we could do 10 choose 6, 0.8 raised to the 6, which means 6 households have to have high-speed internet, and that means 4 of them do not. So we're going to multiply that by 0.2 raised to the 4th. And I could do this on my calculator. I can do, I can just do this all in one go here. I can do, we'll do 10, oops, choose 6, okay. 10 choose 6, whatever that is in my case. And I'm going to raise 0.8 raised to the 6th times 0.2 raised to the 4th, okay? So this comes out to be 0.08808. 0.08808, okay? Again, I could do this on R, and I could do this, again, a few ways. I could do choose 10, 6, and then, which is 210, and I raise that times 0.8 raised to the 6th times 0.2 raised to the 4th, and that gives me the same, 0.08808. I could also do D binomial, and I want 6 successes out of 10 households, or 80% of them have that probability, and I also get 0.8808. So all of these would work. These are also ways we could go about this. Okay, so where did I get the 0.2? 0.2, yeah, is 1 minus 0.8. So if the probability of having high-speed internet is 80%, then the probability of not having it is going to be 20%. Yeah. Exactly. Is that all right for part B? And then for part C, if 10 households are selected randomly, what's the probability that 6 or fewer? So this is a little bit of a pain. So here we have n is equal to 10, p is equal to 0.8, and x is equal to 0, 1, 2, 3, 4, 5, or 6. I have 7 numbers to add up here. I might be able to reduce it a little bit by doing, I could also do 1 minus the probability that 7 or more, and I could do, 7, 8, 9, 10. In either case, I've got 4 of these numbers to calculate. So I can do this. This is going to be most easily done on the computer using, there's a couple ways you can do it. One is you can do dbinom and calculate it for 0 through 6. So let me just demonstrate on the computer. You can do 0:6, and this will find the probabilities of everything from 0 through 6, and I can sum them all up. I can also, there's a function called pbinom that will also give you the same answer. So, did you guys cover dbinom and pbinom in lab? Was that mentioned at all? Pbinom, dbinom, these uses? Yes, no, maybe? Okay. No, not yet. Okay. So basically, so this one, this corresponds to dbinom 6, 10.8, right? And then this one corresponds to dbinom 5, 10.8, okay? And this is the 4, and then this one's going to be 3, 2, 1, and 0, okay? And this one's the 4. And basically, I'm just adding them all up, right? The probability that 6 or fewer have high-speed access, I have to sum. This is going to sum the answers from x equal to 0 to x equal to 6, right? Because that's the probability of getting 6 or fewer. I don't, on the exam, I don't think I would be so mean to have you add up 7 of these numbers. If I asked a question like this, I think maybe a more fair question would be, what's the probability that 6 or 7, and maybe you have to take 2 numbers and add them together, or something like that. I think that's a bit more of a reasonable, that's a bit more reasonable, I think, to ask. Okay. Do we want more examples of binomial? How are we doing? Do you guys want to take a short break? Keep trucking along. Another example of binomial, or another example of something else? Another example of binomial. Okay, you got it. All right. Another example. All right. The crowd has spoken. We want more examples of binomials. All right. Okay, well, I'll just make something up on the spot then. Okay. Can we do binomial where we flip it as in 1 minus? Oh, okay, yeah, that's a good suggestion here. Okay, so let's say I have no idea. Okay, let's say 30% of people. I'm completely making stuff up. Okay, let's say 30% of people have black hair. I don't know. I have no idea. Okay. Maybe higher. Okay. And then let's say we randomly select 6 people. Okay, and then so the question will be, what is the probability that 2 people have black hair? Do you guys want to just try this out yourself? Yeah, why don't I give you guys a couple of minutes to work through this, okay? And then we can share this, all right? And then afterwards we can do problems with the z-table. Yes, I'll be happily do more of those as well. Okay, but why don't I give you guys this problem and you try this out. All right. Do you guys need another minute or? Okay. So we have n is 6, p is 0.3, and x is 2. Right. So 1 is we can go. You can just ask R to do d binom here. You just kind of enter your numbers accordingly. And when you do it in R, it's important you get it in the correct order, and you get around 0.324. All right. You can also do 6 choose 2, 0.3 raised to the 2, and 0.7, which is 1 minus 0.3, and this has to happen 4 times, right? So anyway, you can do this on the calculator and you get the same thing. So you get, on mine, I do 6, choose 2, times 0.3 squared times 0.7 raised to the 4th, and I get 0.324, 135, same thing. I don't know if I should capture my calculator screen as well. It's helpful. I don't know what kind of calculators you guys have. Okay, so another problem is we could say, same setup, we could say, what is the probability that 3 or more people have black hair? Okay, so we're randomly selecting 6 people. What's the probability that 3 or more people have black hair, right? Okay, so let me just write out the possible outcomes. Is we can have 0, 1, 2, 3, 4, 5, or 6 people with black hair. Okay, so 3 or more is 3, 4, 5, or 6 people with black hair, right? And so one approach is we can do probability that x equals 3 plus the probability that x equals 4, plus the probability that x equals 5, plus the probability that x equals 6, right? So that's one way to approach it, okay? We also know that all the probabilities have to add up to 1. So this side will be probability of x equal to 0 plus the probability that x equals 1 plus the probability that x equals 2, okay? And we know that if we added this side plus this, everything would equal 1, okay? And this is what we want. We want this side, okay? So what we can do, this is going to equal the answer will also equal 1 minus the probability of x equal to 0 plus the probability of x equal to 1 plus the probability of x equal to 2. Is that okay? Does that make sense? So when we say what's the probability that 3 or more people have black hair, we could do 3 plus 4 plus 5 plus 6. We could find the probability that x is 3 plus the probability that x is 4, or we could subtract the complement, okay? Because the complement of 3 or more people having black hair is the complement of 2 or fewer. So I could do whatever the answer is, 1 minus probability of x is 0 plus the probability that x is 1 and the probability that x is 2. Okay, so, and we have actually already found this answer to be 0.324135. Okay, and so now I can just kind of I can calculate this. This will be 6 choose 0, 0.3 to the 0, 0.7 to the 6, which reduces to 0.7 to the 6. All 6 people have to not have black hair. 0.7 to the 6 is 0.117649. And then the probability that x is 1 is 6 choose 1, 0.3 to the 1, 0.7 to the 5. So let's just okay. So I enter that and I get 0.3025. Okay, and then so when I add all of these up, I'm going to get 1 minus 0.11765 plus 0.3025 plus 0.324135. 1 minus, how much of these numbers to add up? Okay, so I got this number plus 0.324135 plus 0.117649. So 1 minus 0.74431. And that gives me 0.25569. Okay. I hope that makes sense to you guys. All right. So if I said, what's the probability that 3 or more people have black hair? We could do it that way, and I can demonstrate that. So I could do the sum of p binom 3 through 6, where we have 0.6 and 0.3. P binom, that's what I meant, and get 0.25569. I can also do 1 minus the sum of d binom from 0 to 2, which is going to give me the same. Or I can just do 1 minus p binom 2, 6. So these are all equivalent. And we get the same 0.25569. why don't we take a short break here? We'll take 5 minutes, and then we'll come back and we'll do some normal model problems from chapter 6. I'll happily answer any other questions that you guys might have, linear regression, whatever else we may have. So we'll take a short break. All right. Okay. So we'll let's look at some normal model problems. Okay. Oh, okay. So I have to say, one thing that I think students had trouble with on the on exams is, on the exam, I don't say this is chapter 5 or this is chapter 6 or, this problem is binomial and this problem is probability or anything like that. It's just kind of laid out there. So, so you'll want to become comfortable with being able to identify, what kind of problems are what. So, yeah. So I won't be explicitly saying, this is a normal model problem, but there will be keys. It'll say something like such and such follows a normal distribution, and that should give you, that should be a strong clue there. Okay, so let's take a look here. Okay. All right, so we'll look at 646. It says males SAT scores. So let's try this one out here. Okay, it says, according to the College Board, the mean quantitative SAT score for male college-bound high school seniors in 2012 was 530. Case SAT scores are approximately normal with a standard deviation of 100. What is the SAT score of the 96th percentile? Okay. So here we're going to say SAT comes from a normal distribution where the mean is 530, right? So the mean is 530 and the standard deviation of 100. Okay, and then here we're asking, what is the 96th percentile? Okay, so if I draw a picture, it looks something like this, right? So not 100. Right here we have 530. And what we want to know is, what is this? What is this score? Such that when I shade everything to the left, this area equals 0.96. All right, so what we do is, if we're going to use the table here, what we want to do is we want to find the spot in the table that gives me an area that's very close to 96%. Okay, so in the table, what value gives an area equal to 0.96, right? And then so here I find 0.9599, and that's in the row. So that's about as close as I'm going to get to 0.96, and that's in the row 1.7 and the column 05. So we're going to say Z equal to 1.75, right? And that's because the probability that Z is less than 1.75 is 0.9599. So that's going to be the number that gives something very close to 0.96, okay? And so I'm going to use the z-score formula, x minus mu divided by sigma. This is what we have, and let's plug in what we know. So we know our z is going to be 1.75. Our x is unknown. Our mean is 530. And our standard deviation is 100. So I get 175 is equal to x minus 530. I multiply both sides by 100. And then I add 530. And I get 530 plus 175. And here I get x equal to 705. That's the 96th percentile. Okay. Now, this is important. Do not do. This is a common mistake I see. Z is equal to x minus mu over sigma. And people will plug in 96th percentile, and they'll say z is equal to 0.96. X minus 530 over 100. Okay, this is going to be wrong. Okay, so don't do that. Don't do that. You have to look it up in the table and say what value gives me 96%, and that number is 1.75. Okay, let me do another problem from the normal distribution. Okay, let's look at we'll do there's a lot of SAT score things, huh? Okay, we'll do SAT 6.36. 6.36. Or actually, let's go back. Let's do 634, and then we'll do 636. Okay, so critical reading score was 509. Assume that the standard deviation is 100 and the SAT scores are normally distributed. Okay, so we've got SAT, it comes from normal. The mean is 509 and the standard deviation is 100, okay? And says include appropriately labeled and shade normal curve. Okay, so A says what percent of SAT takers in Connecticut scored less than 600? 600 or less. So we're going to say, what's the probability that SAT is 600 or less? Okay. So our picture looks like this. Whoa, what happened here? Oh my goodness. Oh, geez. Okay, I guess this will have to do. All right. Okay, so we are at 509, and we want to know what's the probability of being at 600 or less. So what is this area? Sorry, let me. Okay, so let's do this. So what is this area? All right, so we have to convert from this. We're going to convert it into a z problem, okay? So our z is going to be x minus the mean divided by the standard deviation. So we're going to have 600 minus 509 divided by 100, our standard deviation. And I'm going to get 0.91, okay? And so I'm going to look up z less than 0.91. Go to our table. So now I get z is less than or equal to 0.91. And then so our answer here is we look this up in the table. So I go to the row 0.9, the column 0.01, and I get 0.8186. So this area is equal to 0.8186. Okay. Part B says what percentage scored less than 509? Well, the mean is 509. So the probability that the SAT is less than 509 is going to be 0.5. Half of 50% of students are going to score lower than the mean if they are normally distributed. So this one's not that exciting. I mean, I could go through the z-score problem, right? I could say z is equal to 509 minus the mean of 509 over 100, and we get a z-score of 0. And then if we look at what's the probability that z is less than 0, that's also going to be 0.5. So we can do that. Okay, so now that we've done that, let's go ahead and try 636 SAT scores in Texas. Okay, so in Texas, it says the average SAT score was 484. Assume the standard deviation is 100 and the SAT scores are normally distributed. All right, so let's go ahead and try this. We've got SAT, normal distribution, 484, standard deviation 100, okay. All right, so here we're asking what's the probability of being between 400 and 500? So this is our, this is no good. Let me shrink this down a little bit. All right. So in the center, we're going to put 484. And the question's asking, what's the probability of being between 400 and 500? Okay, so 400 is less than 484, and 500 is greater than that. And we want to kind of know, we want to know what's the probability of being in this region in the middle here. That's what we want. Okay. So, so what we're going to do is we are going to do area less than 500. So we'll find this. And then we're going to subtract minus the area less than 400. Okay, so we're going to find this area, and then we're going to subtract off this area. Okay. All right, so here we're going to convert 500 into a z-score. Okay, so 500 minus 484 is 16 divided by 100, 0.16. Here I do 400 minus 484 divided by 100, and I get negative 0.84. Okay, so I looked this up in the table. Probability that z is less than 0.16. Go to the table, row 0.1, column 06, 0.5636. So this area is 0.5636. All right, and then we go to the table and we're going to find the probability that z is less than negative 0.84. So I go to negative 0.8, column 04, which I think is this one, 0.2005. 0.2005. Okay, so this area the area is equal to 0.5636 minus 0.2005, and I'm going to get 0.3631. That's our area here. Okay. Do you want to try out part B on your own, or do you want me to just do it right here? Okay, yeah, you can have a minute to try it. All right, you guys go ahead and try part B. What percentage of SAT takers scored between 500 and 600? So go ahead and take a minute to try that out. All right, so here we want to know scores between 500 and 600. Okay, so we got 484. We're going to go to 500 and 600. We want to know what's the probability of being in this zone here. Okay, so I'm going to find the area to the left of 600. And then we're going to minus the area to the left of 500. Okay, well, the area to the left of 500, we've already figured this out. I mean, we could go through the steps again, but this area is 0.5636. Okay, so we've already solved this. This corresponds to, you know, z equal to 0.16, right? So that part's already there. Okay, so now we really just have to figure out probability of being less than 600. So our z-score is going to be 600 minus the mean, 484 divided by 100. And we're going to get a z-score of 1.16, right? So 600 minus 484 is 116 divided by 100 is 1.16. And so I look up this area, probability that z is less than 1.16. In the z table, row 1.1, column 0.06, and I get 0.8770. Okay, so we will find the area in between, okay? So this area in between is going to be 0.8770 minus 0.5636, and we're going to get 0.3134. That's the area in between. Okay, all right, so there's a question, could we try these in R? Yeah, so one way is you could just go, you know, once you find your z-scores, it's real easy. You just type in p-norm. So p-norm is basically the equivalent of using the z-table. So whatever you type in here, it's like if I type in 0.16, I'm going to get 0.5636, maybe with a few more decimal places. So I get 0.5635595. So if I round that off to 4 decimal places, I get the same thing. So I can do p-norm 0.16, p-norm negative 0.84, and I get the same thing, 0.2004, again rounded to 4 decimal places would be 0.2005. Okay. And then, so, you know, so you can do that. And so that's equivalence there. There's also another way, I mean, so if you didn't want to, I don't think it's very hard to calculate a z-score, but if you wanted to, like this answer here of 0.2005, you can get the equivalent by saying 400 mean equals 484, standard deviation equals 100, and you get the same answer. So you can, if you didn't want to bother calculating the z-score, you can type in the numbers directly and say, I want the area to the left of 400, the mean is 484, and the standard deviation is 100. So you can specify it that way. And you'll get the exact same answer. A question, should we use the table or R? So the answer is it doesn't matter. I will, you know, my multiple choice answers will match using the table. So like, but I mean, if you use R, you'll get the same answer. It might be off by like 1/10,000th because of rounding, but my answers. So I will go to the table, which is the equivalent of using R and rounding off to 4 decimal places. So, so it doesn't matter whether you use the table or whether you use R, you're gonna get the same answer. But maybe because of rounding issues, because the table rounds everything off to 4 decimal places, maybe because of rounding issues, maybe that last digit might be ever so slightly off if you use R, but you're gonna pretty much get the same answer, so it doesn't matter. Again, you know, if we were in person and in a classroom, you would not be able to use R because you're not. I wouldn't let you bring your whole computer into the classroom. But you know, you guys are at home and you're taking the exam on your home computer and stuff, and you know, there's no real way to kind of police whether somebody is using R or not. So I'm designing my exams so that, you know, using R will not provide a significant advantage or disadvantage or anything like that. So, so whether you use it or not, we have that. Okay, if it's for p-norm, if it's over 400 rather than under 400, how would you do that? Well, the simplest answer is you would do 1 minus, okay? So you just do 1 minus this, okay, whatever 1 minus is that. There is an option, I believe, when you do p-norm, you can choose an option from lower tail and change it from false, true to false. So you could do p-norm, enter all of this in, and you change it from lower tail to false, and it will give you 1 minus that. I think it's much easier to just do 1 minus than having to type all of this in and type in lower tail equals false. But I mean, the option to change it to say I want the thing on the right rather than the left, right? So by default, it gives you the lower side, the left side. There is an option to switch it up, but it's the exact same thing as doing 1 minus, I think it's easier to do 1 minus, which is basically what you would do if you use the table. Okay, how are we feeling about this? Do we want more examples from the normal distribution? Do we want examples from different sections in the book? This review session is intended for you guys. I'm not, I want to provide you with resources to help you guys feel like you're ready for the midterm. So, so I don't want to waste your time, but so please tell me which chapters or sections you want me to review. Will there be a lot of vocabulary type questions? Yes, maybe. I don't know what a lot is. You know, it'll be something like, you know, I might have a list of things and I might say like, what can you use to measure spread? And you'd have to tell me things like, you can use the IQR and the range and the standard deviation and variance or things like that. I might ask a question, what graphic displays are can be used for numeric data, and you would tell me things like a histogram and a box plot, okay, or dot plot and things like that. Or maybe I'll ask, can you use a bar chart for numeric data? And the answer is no. Can you use a histogram for categorical data? No, you can't, right? So I don't know, things like that, right? I don't know, if you take all of the numbers, all right, so let's say you say if you have a set of numbers and the standard deviation is 5, and then you take all of the numbers and you multiply them by 2, what happens to the standard deviation? And I guess your answer choices would be they stay the same, the standard deviation gets bigger, the standard deviation gets smaller. So if you take all the numbers in a data set, what happens when you multiply everything by 2? And the answer will be that the standard deviation gets bigger, it doubles. The standard deviation gets twice as big if you take all of your numbers and multiply by 2. There might be another question right alongside of that, and you say you have all of these numbers, and you have x and y, and the correlation is 0.8, and you take all of the x values and you multiply them by 2. What happens to the correlation? And then the answer to that is that the correlation stays the same, right? So there's a few things, right? So I don't know if these count as definition or conceptual questions. They're not really calculation questions. There's not like any kind of calculations that you have to do, but you have to know the concept of these things, right? So correlation is not affected by multiplying by a constant or adding a constant. So if I take x and I multiply everything by 2, the correlation between x and y, the correlation is not going to change. So when you multiply something by a constant, correlation remains the same. Whereas standard deviation measures spread. So if you take everything and you multiply it by 2 or 10 or whatever, the numbers get more spread out, so the standard deviation will change. So there's going to be a handful of questions like that. I don't have, the unfortunate thing is I can't think of real practice problems like that, so I haven't provided any practice problems, because either my practice problems that I give will either just give away the answers or the questions completely, or students will complain to me that the practice questions that I gave were nothing like the actual questions that I listed on the exam. So so I don't have a ton of those types of questions in terms of practice for you, but it's good to kind of, I think it's important for you to go through your notes and lectures to kind of make sure you got some of these concepts or definitions or whatever you want to call it. Make sure you have a good handle on that. I've given you a handful of practice problems that are a little bit more calculation based, because I think practice there is good. Are bar charts the only way to display categorical data? Technically, you can do a pie chart, but I have a certain disdain for pie charts. So in the book talks about pie charts, but I don't like pie charts. I've never seen a pie chart that I thought, man, this is way better than a bar chart. Yeah, there's nothing a pie chart can do that a bar chart is unable to do. And in almost every case, I think the bar chart is superior to the pie chart. But yes, you can, for categorical data, you can do bar charts or pie charts. And, but yeah, I mean, there's these esoteric plots that maybe do exist, but pretty much for categorical, pretty much just bar charts, yeah. So, but the book talks about pie charts. I don't know. Any other questions? Okay. Well, I guess I mean it's almost 12:50 anyway, so we'll just cut it a little bit short today. So we'll end here. Good luck as you guys study. So it says, will you be locked into the CCLE site when we take the midterm? So I am not using Respondus. I've chosen not to do that. So you'll just take it on a browser, which means you are not locked into the CCLE site. Okay, so you are not locked into the site. I think, you know, CCLE does log all of your activity, so so that's fine. Just be aware of that. So my primary rule is, because I think I have open note pretty much everything, right? Like open note, open book, open, you know, calculator R, whatever. The only thing you're not allowed to do is communicate with other students. So nobody should be chatting or messaging or emailing or talking on the phone or anything like that. You know, when you take the exam, you should be in the room by yourself. If you have a roommate that you can't kick out of your room or something, just make sure that they know not to like talk to you during the exam. Like I don't want to see you interacting with other people during the exam. If you need to get up to use the restroom, that's fine. But but that's what we've got there. Okay. All right. Well, good luck, everybody, as you study. We will see you guys on Friday, either at 10 a.m. or 10 p.m. And we'll see you guys then. I'll post the recording of this, and I'll post up these notes as well. All right. See you guys then.